So for item 10, we're trying to prove all these statements about sets A, B, C, and D. So for item A, we're going to begin assuming these. So we're going to say let C be a subset of A and D be a subset of B. Since we want to show that C intersection D is a subset of A intersection B, we begin by producing some object that is here, and we have to show that it is also there. So let X belong to C intersection D. Then, by definition, X belongs to C and X belongs to D. So note that C is a subset of A and D is a subset of B. So if X belongs to C and C is a subset of A, so X belongs to A. And if X belongs to D and D is a subset of B, then X belongs to B. Thus, if X belongs to A and X belongs to B, then by definition, X belongs to their intersection, right? So we have shown that, therefore, we have shown that some object that belongs here is also in A intersection B. So our conclusion is going to be C intersection D is a subset of A intersection B. And that's it for item A. So now we want to do item B, which is kind of similar, the structure. So I'm going to leave this there. And now, instead of showing that C intersection D, we want to show that C union D is a subset of A union B. So we're going to follow a similar path of thinking. We're going to say let X belong to C union D. Then by definition, then X belongs to C or X belongs to D. So as C is a subset of A and D is a subset of B, then X belongs to A, because since X belongs to C and C is a subset of A, so X has to belong to A. Or if X belongs to D and D is a subset of B, or X belongs to B. Now, X belongs to A or X belongs to B, it just means then that, so then X belongs to the union of A or B, because that's the definition of the union. Then X belongs to A union B. All right, so we have shown that some object that is here must also be there, so that's enough to show that it is a subset. Thus, C union D is a subset of A union B. That's it for item B. Now for item C, we're going to have if C is a subset of A and D is a subset of B and A and B are disjoint, and we want to show that C and D are disjoint. So we want to say this and A and B are disjoint. A and B are disjoint. So we're going to, the way that we're going to do this is we are going to produce an element in C intersection D and show that it's a contradiction, right? It can't be there since it's empty. So we're going to say let X belong to C intersection D. So, because we want to show that C and D are disjoint, so we're going to do this by contradiction, right? So we're going to say, then X belongs to C and X belongs to D, right? Note that C is a subset of A and D is a subset of B. So it must be the case that X belongs to A and x belongs to B, right? So in this case, we're now going to show that a contradiction has taken place. However, A and B are disjoint. So it cannot be the case that x belongs to A and x belongs to B at the same time, because they are disjoint. They have no elements in common. This is a contradiction so x does not belong to C and D. Now, when I said let x belong to C intersection D, I just chose a, a generic element, right? I assumed nothing about that element except that it was in the intersection. And we just showed that, hey, if it is in the intersection, then it's going to cause contradictions, right? So there are no elements in the intersection. So we're going to say, thus, C and D has no elements, so C intersection D is empty, right? So if C intersection D is empty, this implies that C and D are disjoint. Yeah. So we assumed that there was some element in the intersection, showed that that led to a contradiction, so the intersection must have been empty, thus C and D are disjoint. Oops, and that was item C. I guess I should have put it here. Okay, so for item D, we want to show that if C is a subset of A and D is a subset of B, then D minus A is a subset of B minus C. So let's just change the letter here. So we're going to say let x belong to D minus A. So we begin here because we want to show, hey, if the element is in D minus A, then it must be in B minus C, right? So let x belongs to D minus A. Then what we're going to show here, x belongs to D and x does not belong to A by definition, right? So note that D is a subset of B and C is a subset of A. So if x belongs to D, thus if x belongs to D and D is a subset of B, it must be the case that x belongs to B. And if x does not belong to A, and C is a subset of A, right? It must mean then that x does not belong to C, because C is contained in A. So it must mean that thus x belongs to B, and x does not belong to C. So this fits the definition. So x belongs to the definition of B minus C. So we have shown that some element that was here must also be here, so it means that it is a subset. Therefore, D minus A is a subset of B minus C. And that is it for item D. Now for item E, well, this is going to be a long one. So there are a lot of things that we are assuming here, right? So we're going to say, let A union B be a subset of C union D. And we're also going to say A intersection B be empty, and C be a subset of A, right? So let me just, okay, so we want to show here that B is a subset of D, right? So what we're going to do here is begin with an element in B. So we're going to say let X belong to B. And now we want to show that that it will show up in D, and thus B is a subset of D. So if X belongs to B, then X belongs to, let's see, then X belongs to A union B, because every element that is in B is also in the union, right? So note that A union B is a subset of C union D, so X belongs to C union D. Now, this implies that X belongs to C or X belongs to D. So what we're going to do here is say, note that, actually, we have that X belongs to B and A intersection of B is empty. So this means that X cannot belong to A. So X cannot belong to A, right? Because the intersection of A and B is empty. So furthermore, C is a subset of A. So what this means here is that so X cannot be in C, right? Because if X were in C, then X would be in A. But we know that X is not in A, so X cannot be in C. Thus, it must be the case that X belongs to D, because we said up here that either X belongs to C or X belongs to D, but we just showed that X cannot belong to C, right? And it cannot belong to C because there's X is not in A and C is a subset of A. Thus, it must be the case that X belongs to D. So we have shown that some element that was in B also showed up in D, so the conclusion is that B is a subset of D. And that is it for item E.